Okay, question 6, a Venn diagram question. Let's dive straight in. Part A. State any pair of mutually exclusive events from A, B, C, and D. These are events which don't overlap. So I can say that C and A will be mutually exclusive, as indeed would D and A. So either of those two will get you the 1 mark available here. We're now told that B and C are independent, and we've got to find the value of P, which is the unknown probability within B. So if these events are independent, I can say that the probability of B and C, which actually equals 0.27, will equal the probability of B multiplied by the probability of C. So therefore, 0.27 is equal to the probability of B. So that is P plus the addition of these two guys, which is 0.32. And I'm multiplying that by the probability of C. So that's all the contents of the C circle. And if you add all these guys up, 0.27, 0.25, 0.08, we get 0.6. And if you do the arithmetic and move things around, you'll get that P is equal to 0.13. And that's the answer for part B. So part C, we've got to find the greatest possible value of this probability, which is the probability of A, given that not B has happened. Now, if not B has happened, we can effectively remove the whole of this circle from the diagram. So given the results as they stand, the probability of this is the probability of A, which is Q, divided by the total. So if we want this to be the biggest, it means that R must be the smallest. And the smallest value of R is R equals 0. So therefore our probability will be equal to Q over Q plus 0.33. Also, I can say if R does indeed equal 0, all of the remaining probabilities must add up to 1. So we get Q plus all these probabilities, which actually add up to 0.78, and this must be equal to 1, and therefore Q equals to 0.22. So if I substitute that back into our equation for Q, this becomes 0.22 over 0.55, and this equals to 0.4. So in part D, we're actually given a value for the probability of B, given that not A has happened, as 0.5, and we're asked to find the true values of Q and R. So I've matched our main diagram to reflect the new situation that A is no longer present. A has not happened, and we've got to work out the probability of B. We're told it's 0.5, but breaking it down, the probability of B will be P plus 0.27. Now, P we know is 0.13, so this is 0.13 plus 0.27, and that's divided by those same values, 0.13 plus 0.27, plus R, which is sitting on the outside of everything, plus these two added together, which is 0.33. So simplifying a little bit, this is 0.4, and this is divided by R plus 0.73. And if you cross-multiply and rearrange, you'll get that R is equal to 0.07. If you add everything up, you'll get that 1 is equal to Q plus 0.85, which gives a value of Q as 0.15. And those will be the answers to part D. So in part E, we've got to find this arrangement. So A union B, so that's everything in A and everything in B, turn to black. So without any linkage to C, at the moment we've got R plus 0.25 plus 0.08. But we need that area and this area. So what is now being excluded is R. So this is equal to these two guys added up, which is 0.33. and that will be the answer to part E. And lastly, in part F, we've got to use set notation to write an expression for the event with probability P. That's this area here. So clearly we want B, but we don't want anything to do with A. So we'll do this with intersection of not A, which is known as A prime, and we can do the same with C. So this is and not C. And there's the answer in set notation. And that ends this question and the paper.